Let's talk a second about the Pearson Product Moment Correlation. The statistic is small r. This lecture is copywritten by the Probe Consulting Company and Dr. C.H. McManus, 2007. All rights reserved. Excuse me. We're going to talk about the central limit theorem, inferential statistics, and the Pearson Product Moment Correlation. Again, the stat is small r, and Pearson will look at the relationship between two variables. The relationship between two variables. We talked in the last lecture about probability, alpha, and so forth. So please make sure you understand that. We're now saying, how do I inferential, from a sample to a population? And to do so, we use the central limit theorem as our basis. Okay? Small n is our sample, large N is the population. We make assumptions about large N based on small n because we can understand what's happening in the sample because we can control and look at that. And we estimate from that what's going on in the entire population. And that's what we call inferential statistics, based on assumptions that what I find in my sample, I should also find in the overall population. Central limit theorem states, as the sample gets larger and larger, and if you choose your sample at random from a normal distribution, not skewed but normal, you will approximate population parameters. That is your central limit theorem. In two parts, your n must be bigger than 30. You must choose your people at random, again, from a normal, non-skewed distribution. And you know what skewed means from our first exam. Research, by definition, is a careful, diligent search. We're looking for atypicality and typicality. We only know what is abnormal if we know what the norm should be, if we know what is typical. We look at independent and dependent variables, and we call those IVs and DVs. IVs you make a choice about. For example, if you're going to study gender, gender because you chose gender is your IV. You can then look at some aspect of gender. Let's just say GPA. Then GPA becomes your dependent variable. We assume that GPA depends on someone's gender, hence IVs and DVs. Pearson correlation, the next big thing. Again, Pearson is about relationship between two variables. There's an y-axis going up, x-axis going across the bottom. And you don't compare, but you look at variables and see their correlation by charting them on this A, Y, and X axis. Remember, Pearson does not imply causality. There is no cause and effect. You aren't saying that someone's score on something is causing something else. You don't say that a person's study time is causing their midterm to go up. You just say that there's a correlation between study time and midterm grade, but there is no implied cause and effect. This correlation can be linear, on a line, straight line. It can also be on a curvilinear, which means it makes a little U shape. It can be positive or it can be negative. If your correlation is positive, then both scores go in the same direction. Either they both go up at the same time or down at the same time. That's positive. If one goes up while the other one goes down, that's negative. Let's talk about positive. The more you study, the more your exam scores may go up. The less you study, the more they tend to go down. They're going the same way, up or down, that's positive. Negative. The more you run, the more weight you lose. So you run more, that's going up, weight goes down, that's negative. And if there's no correlation, like shoe size and GPA, that is a non-correlation. Correlations are on the scale that you see here, from -1 to 1, excuse me, with 0 in the middle. The closer the Pearson is to the absolute value of 1, the stronger the correlation. Absolute means the sign does not matter. A -1 is as strong as a 1. We talked before about hypothesis. Your null is R equals 0. Variable 1 and variable 2 do not correlate. You choose your alpha. We talked about alpha before, and the stat is the Pearson R. Here are examples of what you may see. You see R right here. That's the stat. This 84 here is your degree of freedom, which is your N minus 1. And your Pearson is -0.4567. Alpha less than 0.01. That's an example of what you may see for the Pearson. Same thing, R, DF, and so forth. In SPSS, you will find the output for the Pearson that looks just like this. Every variable that you see up top here also goes down the side here. And where they intersect is where you find on the top line the Pearson, on the second line the alpha, on the third line your N or your sample size. So the correlation between number of coconuts in the Gilligan data set and amount of sand is -0.577. That's the correlation. It's a negative correlation. 0.577, alpha 0.008, my N was 20, so on and so forth. When you see these ones here, that's where the two variables come together. So coconut, coconut, fish, fish, sand, sand, ships, ships, hats, hats, and so forth. And that concludes our discussion on the Pearson Product Moment Correlation.